The height s of a rock after t seconds when propelled straight up with an initial speed of 80 feet per second from an initial height of 20 feet can be modeled by the function s of t equals negative 16t squared plus 80t plus 20. When will the height of the rock be 50 feet? Round your answer to the nearest tenth of a second. To set this problem up, we need to first recognize that if we want to find how long it will take the height of this rock to be 50 feet, we are actually asking ourselves to set s of t equal to 50. So to set s of t equal to 50, we have this quadratic equation. Negative 16t squared plus 80t plus 20 is equal to 50. And to solve this quadratic equation, we will solve it using the quadratic formula. So let's subtract 50 from both sides and get negative 16t squared plus 80t minus 30 is equal to 0. Now let's divide both sides by 2 to make our numbers a little smaller and a little easier to deal with. So I'll divide everything by 2. When I divide everything by 2, I get negative 8t squared plus 40t minus 15 is equal to 0. Now, plugging these numbers into the quadratic formula, I get t is equal to negative 40 plus or minus the square root of 40 squared minus 4 times negative 8 times negative 15, all divided by 2 times negative 8. Now, if I simplify this, I get t is equal to negative 40 plus or minus the square root of 1600 minus 480, all divided by negative 16. And if I keep going, I get t is equal to negative 40 plus or minus the square root of 1120 divided by negative 16. Now in the problem, it did say to round our answers to the nearest tenth of a second. So what we can do here is just pull out our calculators and approximate what this is. So t will be approximately 0.4 and 4.6 seconds. So it'll take 4/10ths of a second and 4.6 seconds for this rock to reach 50 feet.